Welcome to our Flutter course. This is your one-stop spot to master on project structure, email and social login, push notification, CRUD Operations, AWS Amplify, and many more advanced topics. The best way to learn is by doing. So you learn all those by building this beautiful recipe app. On the first screen, you'll see buttons to register and sign in. To sign up, use your email or choose Google or Facebook. If you are already a member, sign in with your email or Google and Facebook. Once logged in, you will land on the home page with list of recipes. Tap any recipe to view its details. To save it, tap the bookmark icon. Check your saved recipes on the bookmark page. Tap the icon again to remove a saved recipe. Search for a dish like pizza. If you back again to the search, it shows pizza on recent searches. You can also add your own recipe. Fill the title, image, categories, and other details, including ingredients. Not just that, you can update your own profile. The best part, we have also added push notification to the app. Close the app, open it again. See, it remembers you are logged in and takes you straight to the home page. This course is made by someone with over 15 years of experience in software industry. Let's hear more from him directly.
Hello everyone, I'm Salih and I work as a senior developer advocate with AWSAmplify. In this video series, you will learn about how you can create a recipe application by using AWSAmplify and Flutter. But before we start off with the implementation, let's talk about what is AWSAmplify. Imagine that you have an idea. You want to build it as soon as you can. You know how to do content. It can be a mobile app, cross-platform app, it can be a web application, and you want to power them with cloud. How you can do it? We built Amplify to make it easy for front-end developers to build full-stack applications. With AWSAmplify, you can be a full-stack developer by having your cloud running for you, by creating the backend with the tools that we provide to you. Also, you can host your web application and build your UI, and connect the backend that you created by using Amplify libraries and UI components that we provide to you. AWSAmplify support React, Vue, Vanilla.js, Swift, Android, and last but not least, Flutter. Let's talk about Amplify Flutter library. Amplify Flutter libraries support all the platforms. They have been rewritten with Dart, and they support not only mobile, but also web and desktop platforms. You can extend the capabilities of the previous libraries by updating the version. Amplify Flutter has Authentication, GraphQL API, REST API, storage, push analytics, and a UI library for creating easy authentication. In this video series, you will learn about authentication, GraphQL API, storage, and push notification. In addition to this, you will also learn about how you can create a Lambda function to extend the capabilities of. If you are ready, let's get started. We are going to be learning about adding an authentication flow by using AWSAmplify. That will include manual sign-in and Google and Facebook social sign-ins. You will be learning this by using AWSAmplify's Flutter libraries. We will be using the recipe application that's already equipped with basic functionality using mocked information. Before we jump into the authentication part, let's take a quick tour of the current state of our recipe application. Once you run the starter project, you can see two buttons will welcome you. There will be a register page and a sign-in page. Each page will have information about email and password. In addition, you can also sign in by using social sign-ins. Click on any button to move forward to the app. Once you land to the app, you can see the latest recipes page. You will also see the Save It page, Profile page, and if you go, you can see that it has many features like search, adding a new recipe, notifications, and many more that you're going to be implementing throughout this series. This means we have implemented all the necessary pages for you. You will only focus on the AWSAmplify implementation during this video series. Exciting, right? If you're ready, let's get started. To initialize an Amplify project, there are two things that we need to have. First, an AWS account, and second, a configured Amplify CLI tool. You can install Amplify CLI by running this npm command. Afterwards, you need to configure your Amplify CLI with Amplify configure command. This will connect your AWS account to the CLI. In this video, we will not go through the installation and configuration process. However, I will leave you links in the description for installing and configuring Amplify CLI. Once we configure Amplify CLI, first thing we need to do is to navigate to the Flutter project and run amplify init command. Once you run the command, follow the on-screen instructions to set up your backend. First instruction is defining a name for the project. You can either define a name by yourself or use the default one. Once you define your name, press enter. After you define your name, it will give you a set of default configurations. You can see that it can understand the web type. It selects a default editor and creates an environment for you to work on. You can either define these one by one or click on enter and continue. Now the CLI will ask you the way to authenticate your application. You can select either AWS profile or AWS access keys. Since you already connected your AWS profile with the CLI, you can select AWS profile. Select whichever profile that you would like to use. For the sake of simplicity, I will select the default one. Now it will deploy the root stack for your application and generate resources for it. Once it is deployed, the CLI will ask you if you would like to send some non-sensitive configuration data on failure. You can say yes or no to this, it is totally up to you. I will select enter and say no. And congratulations, now you have initialized an Amplify project. Next step is to add authentication to the project. For that, write Amplify add auth and click on enter. You can define everything about your authentication, but for the sake of starting off easily, we will select the default configuration. Select the sign-in type as email. Besides that, we are not going to do anything at all, so you can say no to this. After that, it will tell you that everything is alright and you have successfully added authentication resources. Now it is time to provision the authentication resources on the cloud. For that one, run Amplify push and create the necessary resources on the AWS backend. In a few minutes, it will add everything to the cloud. Now it is time to use these resources with the Flutter project. For using the resources, AWSAmplify team provides you a set of libraries. First two that we are going to be using is called Amplify Flutter and Amplify Auth Cognito. Amplify Flutter is a top-level Flutter package for the AWSAmplify libraries. It helps us to configure the libraries and use them. Amplify Auth Cognito, on the other hand, is the category plugin used in the AWS Cognito provider. One important point to mention about Amplify Flutter libraries: after 1.0, almost all the categories are supported not only on mobile, but also on web and desktop. For checking these in detail, refer to the documentation which is shared in the description section. Now let's add these libraries to the Flutter project. For adding Amplify Flutter, write flutter pub add Amplify Flutter and click on enter. Now it is added successfully. For adding the authentication library, also write flutter pub add Amplify Auth Cognito and click on enter. In pubspec.yaml file, we can see that two libraries has been added successfully. This shows you can add these libraries either manually by copying the name and the version from the pub.dev or using the CLI. I use the CLI way, but the decision is up to you. Once you add the libraries, be sure to write flutter pub get to fetch the latest resources of the libraries. Now we are ready to configure the Flutter libraries in the main.dart file. In the main.dart file, we will create a new function. The function is called configure amplify. In this function, we are doing two important things. First, we are adding the plugins that we are going to be using. In here, I have a suggestion. If you are going to be only using one plugin, you can use a function called add plugin instead. Since I know that we will be adding more plugins, I will be using add plugins here. After adding the plugin reference to a list of plugins, now it is time to configure the information about Amplify app. This information comes from Amplify config variable. This variable is generated for your project and it is under Amplify configuration.dart file. Now let's call the configure amplify in main function. Once you're done, restart your application from scratch. In the meantime, please keep in mind that Amplify requires a minimum of API level 24 on Android and 13 on iOS. Now that app ran without any failures, we can be sure that Amplify is configured. If there was an exception on the Amplify side, SafePrint method here was going to print it out to the console. Good thing about this SafePrint method is it is only going to work on debug, so you can use it safely. Now that we have configured the Amplify library successfully, let's use authentication functions to generate the users and sign in and register them. To start implementing the authentication functions, you should go to Share, Implementation, and Mock Authentication Repository class. In the class, you can see that all of these functions are in the mock state, meaning that whenever they are called, it just waits for a second and returns. Find the sign up function in the file. We will start up by implementing that. There will be two parts of this implementation. First is the sign up. Second is the error handling. Let's start by checking out the sign up function. You can see that we are providing the email and the password to the sign up function here. One thing that might confuse you is that we are giving the email to the username property. The reason is that by default, Amplify will expect you to use username. However, as you might remember in the previous step, we have picked the email information. Because of that setup, your email is actually your username. Also, you're defining the email in your sign-up options as well. Extra information like name, gender, and many more can be added to the sign-up options. If this operation ends successfully, you will be redirected to the user confirmation page. But if there is an exception, you will be able to handle it in the catch clause here. Thanks to the feature from Dart 3.0, now you can do pattern matching for the exception. You can print out the error to the console. After you get the information, you can rethrow. This means whatever calls this function will get an error clause as well. After the registration, you have to confirm the user. For user confirmation, you will receive an email with the confirmation code. AWSAmplify will send that email by default, so you do not need to do anything extra about it. Let's see what you need to do to confirm the user. For confirming the user, you need to have the email address and the confirmation code. Afterwards, you need to call Amplify Auth Confirm Signup function. This will require the username, or in our case, the email, and the confirmation code. Once the Confirm Signup call successfully happens, this means it will not have any exception. You should be ready to have the login functionality implemented. Once you have the email and password, what you need to call is Amplify Auth Sign-in function. This function will return a result. According to the result, a user might be signed in, or they might require an extra step to do. For example, in this case, they might need to do a confirmation for their sign up if they haven't done it before. In here, what we do is throw an exception and say that, hey, this user is not confirmed. However, if the user is signed in, then we generate the current user information to be used in this page here. You can see that we are handling a few authentication exceptions here. One of them is user not found exception, the other one is user not confirmed exception, and if it's a default exception, then we just print it out and rethrow again. And this will be enough for user login. Now let's generate the information for the current user. For generating current user information, we are going to make two different calls. First one is going to be a primitive information call to get the current user. And the second call is going to be used to get the user attributes. For the first, we are going to call Amplify Auth Get Current User. For the second, Amplify Auth Fetch User Attributes. Once we have results for that, we are going to combine these information in a user model that we have created in the starter project. The user attributes here will return a list of key value pairs, and the current user will return information such as user ID. In the user model, we are keeping information about ID, name, email, profile picture, and many more that you would like to keep. This user model is assigned to the current user variable. And that current user model helps us to get information about the name, full name, and email that we are going to be using in the application. At the moment, the user logged in information comes in a random way. However, if we already have a logged in user, we don't want to go through the login process again. We want to land them to the home page directly. For that purpose, we need to fetch the current authentication session. For fetching the current session, you need to call Amplify Auth Fetch All Session. That should be enough to get the current session. However, I would also recommend you to use the Fetch Auth Sessions options to refresh the token when it needs to refresh. If a user is already signed in and their token is expired, you won't be able to use the token from that user for making API calls or any other call at all. Once the token is refreshed, you can refetch the current user information and be sure you are up to date, and return if the user is signed in or not. Now that user login flow is implemented, let's restart the application from scratch. Okay, now the application is running. Let's register our first user. Click on the register button, enter the name information, email address, and the password. Once you fill out all of these information, click on the sign up button. As you can see, it will ask for a confirmation code. Check out your email address and you should receive an email like this. Go back to the app and enter the code and confirm the user. Once the user is confirmed, now you can log in. Enter the email address and password information. Now click on login. You can see that you have successfully logged in and you have a new name here. If you click on the sign in button, you can see that we have 3 different functionalities that we didn't implement yet. The first one is forgot password. The second one is sign up with Google and sign up with Facebook. Let's start to implement that. First, forgot password. Click on the forgot password button. It will take you to a form that you can enter your email address and they will send you a confirmation code. Let's go to the forgot password function and update it. In the forgot password function, you will call amplify auth reset password and pass the email address as your username like we did before. If the reset function doesn't fail, you will receive a confirmation code. Otherwise, you will get the exception over here. Let's hot reload the application and enter our email address. Then click on the reset password button. Once the function is successfully called, you can check that there is an email that you have received. Also, there's a new field for adding a new password. For having a new password, you need to have confirmation code, the new password, and the email address that user has. Let's see how we can use this information to update our password. For updating the password, you need to call amplify auth confirm reset password function. Into that function, you need to provide the information that we have. Once the function call is successful, you're ready to go with your new password. Let's do hot reload again and see everything in action. Our confirmation code is 348055. Enter that information. Next, add a new password. My previous password was number 8 written 8 times. The new one will be Salih123. Click on the confirmation button. Once it is successful, it will take you back to the sign-in page. First, let's try to sign in with the previous password. Now click on the login button. You can see that the error message is incorrect username or password. Let's use the new one and click on login again. Now you have successfully logged in with the same user. Last 2 things that we are going to implement with the authentication flows is the social sign-in with Google and Facebook. First thing that we are going to do is to go to the Google Developer Console. Click on the project drop-down button here and then new project. Give a name to your project and click on the create button. Once the project is created, click on the select project button here. This will update the selected project. Then click to the navigation menu here. Go to API and services and go to the credential. Once you land to the page, you can see that it will ask you to create a consent screen. Click on the button here to configure that. Click on the create button. In the app information screen, write the name of the app and add an email. The logo, the domain, and authorized domains are optional, but be sure to add developer contact information here and click on save and continue. Keep on clicking on save and continue and go back to the dashboard. Now next, click on the credentials again. In the credentials menu, you can see the create credentials page. Underneath, you need to click on auth client ID. From the application type, select the web application here. Give a name to your client ID and click on the create button. Once the client is created, keep this page open and go back to your terminal. In the terminal, update your authentication settings by writing amplify update auth. Once you run the command, it will ask you a few options. Select the one about the social provider, which is apply default configuration with social provider. First question is, what domain name prefix do you want to use? Let's keep the default one. It will ask about your sign-in URI. meaning that when the user is signed in, where should they land? You can define it according to your app and your needs. I will name this Amplify recipe. You can say no to this because we don't need any extra sign-in URI. Define your sign-out URI as well. If I didn't have a system to redirect the user to the sign-in page, I would have written here sign-in. But right now, I would just write Amplify recipe as well. And I will say no to this. Now it is time to select the Google out of this and add the information about it. First, it will ask me about Google Web Client ID. Copy it from here and paste it to your terminal. Next, it will ask you Google Web Client secret. Copy the secret from here and paste it to the terminal. Once you are done with everything, push the changes to the cloud. Write Amplify push and run the command. After everything is pushed, go back to the Google Developer Console. Click on OK and stay in the credentials and find the created credentials. Click on this one. We will add 2 new information here. But before we do, go back to the terminal and write Amplify status and run this command. Copy the hosted UI endpoint here and edit the authorized JavaScript origins. Next, go to the authorized redirect URIs and click on the add URI button. Paste the same link here and add OAuth to IDP response. Then save your client like you have here. Next thing that we are going to do is to go back to our project. Find the Android manifest.xml file and add a new intent filter. Don't forget to change your URL schema like you had before. This will help us to find our way around Google sign-in in the Webflow. After you add the intent filter, go to the top of the manifest and paste the queries on top of the application. Now find the login with Google function and update it as follows. For login in, you need to call sign in with web UI from Amplify Auth. This will expect a provider, and for that you will give the auth provider that you have defined. Besides Google, you have Facebook, Amazon, or anything that you would need. If the call is successful, you will generate the current user information like you do. Otherwise, you will print out the exception error and rethrow everything. There's a really important point to mention about social sign-in. Once you select a provider, you also need to define the capabilities of that provider as well. For this purpose, you need to go to the Amplify console and make up some changes. In the console, click on the sign-in experience. In the sign-in experience, find the identity provider. In the attribute mapping, be sure you have all the names that is necessary for you. Most likely when you created the application for the first time, you will have the email and the username. However, if you click on edit, add the extra attributes, you can have more information about your user. Now if you go and restart the application again, after the application started, click on sign in and click on the sign up with Google button. Once your user is signed up or signed in, you will see their name right here. And if you go to the information page, you can see that there's this name here and you can see the related information, email, and their full name. You can log out from them and you will end up in the first page. Last step of the authentication flow is to add Facebook login. For this purpose, we will go to the Meta for Developers page. You need to sign in with your Facebook credentials and go to My Apps section. In the My Apps section, click on the Create App button and afterwards select Allow people to log in with their Facebook account and click on Next. Give a name of the app, provide an email address, and select the optional business account part. Once you're done with that, click on the Create App. Next step is to click on the Settings and click on Basic. You can see that there's an app ID, app secret, display name, and everything that you need here. You will be using the app ID and app secret later on to add the Facebook login. Now next step is to open up our terminal and add the Facebook functionality. First thing that you need to write is Amplify Auth Update. Once you run the command, go to the Update All Social Providers and select that option. Select the Facebook and click on Enter. Now copy the app ID from the Meta for Developers console. Paste it here and click on Enter. Go back to the console and copy the secret and paste it here as well. Since we are doing an update, the CLI might ask you about Google Web Client ID for you. You can get that information from Google Cloud Console at the credentials section that you had before. On the right side, you have the client ID and the client secret. Paste them both to the terminal and click on Enter. Now you are ready to push your changes to the cloud. Run the Amplify push command now. Now that everything is pushed to the cloud, go back to the Meta for Developer console and do the last part of the setup. Before you go, be sure to copy the hosted UI endpoint. In the console, click on the product. And under the Facebook login, click on the configure and click on the settings. To the valid OAuth redirect URIs, paste the hosted UI endpoint that you have and add OAuth 2 IDP response to it. Once you add that, save your changes. After you add the OAuth redirect URI, go to the use cases and go to Authentication Account Creation and Edit. If you do not have it already, select the email. This might require you to have an approved business account, but for testing purposes, this should be enough right now. Now let's go back to the code. Find the login with Facebook function and update it as follows. You can see that only difference between the Google and Facebook one is the provider. Once you're ready, restart your application again. Now the app is running, but before we sign in, let's go back to our AWS console and be sure all the information that we need is there. In the AWS console, go to the Amazon Cognito, User Pools, and your user pool. In the Sign In Experience tab, go below. You will again find your federated identity provider sign-in. Click on the Facebook one, and you will see that in the attribute mapping, you have the email and username. Let's update that. Click on the Edit button. Select the Facebook Graph API version. If you're wondering about which API version to use, you can go to the Settings, Advanced, and you can see the number here. The latest one is 17, so I will select that one. And click on Add Another Attribute. Select the name property. Also select the name from the Facebook Graph as well. Since we don't have the profile picture attribute from the Facebook Graph, we are not going to add any more attributes. Click on Save Changes and go back to your application. Now click on Sign In, sign up with Facebook, add your email address and password, and click on Login. After you are logged in, you should see there's a name here, which is coming from your Facebook profile. You can click on here, and you can see there's a full name, and you can see the email address related to this profile as well. If I go back and click on Logout, now I will end up in the starting page. Before we sign off, do not forget to change off the class and the file name as well. With this change, now you have learned how to register a user, log in with a user, and use Google and Facebook sign-in for your application. If you have any questions or comments, ask them here in the comment section or send me a DM over social media. Have a nice day. You have learned about how you can initialize an Amplify project, and also you have learned about adding an authentication flow by using AWSAmplify with either manual sign-in or social sign-in for Google and Facebook. In this video, you will learn about how you can create, read, update and delete information from GraphQL API by using AWSAmplify. Previously, the information was retrieved from the local repository. With the API implementation, you will be able to keep this information on the cloud as well. If you're ready, let's get started. First thing that you need to do is to open up your terminal and go to your project. Once you're at the project, write Amplify add API. Once you run the command, it will ask you to pick from GraphQL API or REST API. Pick the GraphQL. Once you pick the GraphQL API, it will ask you about authorization mode and conflict detection. You can ignore the conflict detection for now. It will be out of scope for this video. Go to the authorization modes and select it. It will give you a few chances to have different types of authorization modes. You can have API key, Cognito user pool, IAM, Lambda, and many more. The default is the API key, but select the Amazon Cognito user pool for change. Since we already have the authentication, we don't need to do anything extra here. Select Continue now. GraphQL API gives you a few chances to select from a schema. You can have a single object, one-to-many relationship objects, or an advanced example. Since you are going to write your own schema, you can select anything. So just click on Enter. You can say no to this. And now you have successfully added GraphQL API capabilities to your project. But keep in mind, it's not pushed yet, so it's not on the cloud. Before we push everything to the cloud, we will work a bit on our GraphQL file. For that, let's go back to our project. Under Amplify, Backend, API, there's a schema.graphql file. Open that up and update it like the following. In this file, you are defining your schema, the information about your models. For creating your schema, each model needs to start with type and the name of the type. After these two, you need to give an annotation called model to define that this is actually a model. It will be useful for code generation. Lastly, you need to define authorization rules for your model. Mainly, there are 3 different authorization rules that you can give. First one is public. It will be open for everyone. The second one is private. It is going to be available for everyone who is logged in. And lastly, owner. Only the owner can see it. You might be wondering, can I have model rules for my model? The answer is yes. You can define different access rules for different operations. For the recipe model, we have an ID, we have the title, serve, duration, category, description, image, duration unit, and ingredient. The ID is a special type that defines the ID of this model. The string and int is the classic primitive type. An exclamation mark next to it defines that this is a non-nullable type. Duration and category are custom enum types that we are going to define. And lastly, ingredients is a list of string which holds non-null objects. For creating custom enum types, you just need to define an enum and name of the enum. Now that you have defined your model, let's push everything to the cloud. For that, go back to your terminal and write Amplify push. The deployment is successful. However, there is still an open question. How we are able to use this model in our project? The answer is code generation. AWSAmplify generates model classes for you. All you have to do is to write amplify code gen models. After you run the command, it will get the schema.graphql file and generate the models for you. If you go back to your project, you will see a new folder. If you open that up, you will see all of your model related files here. After the model generation, next step is to add Amplify API library. For that, open your terminal again and write flutter pub add Amplify API. Once you run the command, it will add the Amplify API libraries to your project. We need to configure the API library now, so go back to your project. Also write flutter pub get to download the libraries to your machine. Open up your main.dart file and add the API plugin to the plugin list. Once you add the API plugin, you also need to provide the model provider. This comes from the generated file and it gives an instance of the generated model. Now let's go back to our recipe repository and try to add a new recipe on the cloud side. In the add recipe function, we have everything that we need. In the current version, we are saving everything locally. Let's use the saved up information and send it to the cloud with the generated model. This is the name of the model from the generated file, and the local file are the same. When you import the recipe.dart from the generated file, be sure to give it a namespace. This way, when you want to call it, you will call it as remote.recipe, but you will make a difference. First thing that we have to do is to import the Amplify API library and a few files. Also, you might realize that we are hiding duration and category from these libraries. The reason is they're clashing with the enum types that we have created earlier on. If we are not going to use them, which in our case we are not, we can just hide them and tell the compiler that we are not going to use this type. For the generated recipe file, we are defining it as remote. Because the recipe model from the initial implementation is also called recipe.dart. Or using them both at the same time, we need to define a namespace for it. That is why we call this as remote. This means when we are going to use this model, we will call it as remote.recipe. If you're ready, let's see how our code looks like. After saving the recipe locally, first thing that we do is to create a remote recipe object. It will get every information from the local recipe that you have created before. But you might realize that for the duration unit and category, we are calling 3 different functions. When we save the recipe locally, our duration unit and duration type are saved together as a string. However, for the remote recipe, the duration type is saved with an enum. That is why first we call the toRemote duration unit and get the number value from the string. For the duration type, we also get the text of duration type here, do pattern matching, and return the correct remote duration type. We do the pattern matching for the category and return the correct category type as well. For the GraphQL, every operation is called mutation. So for each model, when you want to have a mutation, you will call model mutation and the mutation type. Afterwards, you just pass down your model. This will create a mutation request. However, if you want to execute the mutation, you need to call Amplify API mutate and pass down the request. With the response property, you can wait for the result, and if there is an error, you can act on it. Otherwise, it will be successful. Now let's rerun the application again and see how it looks like. Now the app is running, let's add a new recipe. You can fill in information in any way you want. I just pick ramen because I love ramen. After you fill out everything, click on this button here. Now the ramen is created, but there are 2 things missing. First, the image. We will see how you can upload image later on. But second and most importantly, right now we are reading the ramen recipe from the local story. You will see how you can read it from remote as well. But at the moment, it's not implemented. So let's go to the AWS console and see if this information is on the cloud. In the AWS console, go and find your project. Once you open up your project, go to the API tab and click on View in AppSync. In the AppSync, click on the query and create a query to get the recipe. From the recipes, get the title and description of the item and run the query. You can see that our item has been created successfully on the cloud. Even though we see the created item here, it is not useful for the application. For that, we need to read it from our application. For adding the reading capabilities, go back to the project. Right now, we listen to everything from the local database. However, we can also get the latest result from remote as well. There are multiple people using the application. Each of them are adding a new recipe. Our local database will not be able to catch up with the latest changes. Let's create a new function and query the remote recipes. First, we will create a request. The request will be a query to list everything related to the recipe type in the remote format. Once the recipe is created, call Amplify API query and pass a request here. Like you did for the create operation, you can wait for the response and check if there is any error. If not, then get the data and cast them into remote.recipe format. Since the compiler said the recipe can be nullable, get rid of the nullable types as well. Afterwards, map the remote recipe into the local one. This will create a recipes list in the local recipe format. And lastly, save the new ones into the local database. After you create the sync function, call it inside the listen latest recipe. Since this function already subscribed as a stream, once you sync the changes, you will see it automatically on your home screen. Now that the implementation is there, let's start an iOS version of the application and create a new recipe there. And if we restart our application on the Android side, we will see the new recipe over there. Now I ran the application on iOS. You can see that I used the Salih one from the Facebook on the Android side and logged in with the email one on the iOS side. Now let's create a new recipe on the iOS side. I fill out the form and now I will click on this check mark. The recipe is created, but we do not see it here. Now let's restart the application on the Android side and see how the syncing works. You can see that after the syncing, now we have the hamburger. Now we have learned how you can query the list of items from GraphQL API. However, since this is not real time, you have to call the sync remote changes function every time you start the project. Now let's see if we can listen to the changes in real time. For listening to remote changes, you need to create a subscription for the model. You can listen to the events on create, delete, or update. In here, we are creating a subscription request for creation event on the remote recipe mode. Afterwards, we call Amplify API subscribe and give the request here. For the result of the subscription, we listen to the event. And every time there's a new recipe, we map that into a local recipe object and save it in our database. Let's call this function with the latest recipes as well. Now restart both of the application. Now I will add a new recipe and hopefully we will see a new version of it without restarting the application. After filling out everything, let's tap the check mark. You have seen that immediately we have the reaction. But now you have also learned about how we can listen to the changes from the remote. If you take a close look at the items, when you slide them over, you can delete them. However, as you can see here, it's a local operation. So if I restart my application again, you can see that it comes back. Since we want to be consistent on the cloud, let's add a deletion operation by using our GraphQL API as well. Let's update the delete recipe function. We use the model mutations like we talked about before. Differently, we are calling a function called delete by ID. We provide the type of the model and what kind of identifier that we are going to be using. In this case, it is the ID. Then we call Amplify API mutate, get the response from it. If it has errors, we throw an exception. Otherwise, we remove it locally as well. Let's restart our application and delete the object and restart the application again. You can see that the item doesn't come back. And now you have learned how you can delete items on the GraphQL API as well. For the update operation, first, we need the file upload capability. With the file upload, we are going to add a new image to the ramen or update it later on if you want to change it. For implementing the file upload operation, go back to your terminal and write amplify add storage. This will ask you to select from one of the mentioned services. Select the content because we are going to keep only the images there. You can give your project a name here, use the default one, and you can also provide a bucket name. The buckets are specialized folders for keeping your files, and the name of it should be unique universally. So select the default one here as well. You can define who should have access. Select auth users only and give them a chance to have create, update, read, and delete the file. One big advantage of storage is you can connect the S3 bucket events to the Lambdas, so you can do complicated operations by using AWS as well. For now, we won't need that, so click on it. Now that you set up everything locally, let's push our changes to the cloud and run the Amplify push command. After the deployment, now it is time to add the libraries to the project. Write flutter pub add amplify storage S3. This will add the storage library to the pubspec.yaml file. Write flutter pub get to download the library to the project. Now let's go back to our project window. Open the configure amplify function in main.dart file again. Add the amplify storage S3 to the list of plugins here. And open mock storage repository class to upload image and generate the download URL from the S3 bucket. First, update the upload image function. With the upload image function, you provide a path of the file that you selected. And on progress update, you let the user know about the changes that happened to the file during the upload. Here, you define a unique key that is associated for the image that you want to upload. You call amplify storage upload file to start uploading process. You let the storage know about the key of the file. And with the storage upload file option, you give access to every authenticated user to read this file. On each update, you do the callback mechanism and you return the key of the file. Now let's update the generate download URL function to give us a chance to create URLs to reach out to the files that are uploaded. For generating the URL, we will call amplify storage get URL function. We will let the function know that we want to have this file with the guest access like we have defined before. And last but not least, we will define the key here, which is our identifier for the file that we want to have. Afterwards, we will return the URL that has been generated here. Now let's rerun the project again and see how it looks like at the moment. Currently, we are still showing the placeholder image. We will do the updating mechanism in a second. First, let's see what happens when we add a new recipe. Now we have created enough information about the next recipe, so click on the check mark. We have seen that we actually had the uploading feedback, and once everything had settled in, we could also see the image that we have uploaded as well. But that is a good start. But let's see how we can upload a file and also update the GraphQL API. At the moment, update recipe only updates the local database. However, we would like to update the recipe on the cloud side as well. So how we can do it? Now let's update the recipe as follows. First, we create a remote recipe instance by using the updated local recipe. Second, we are calling model mutations.update like we have for delete and create, and pass the remote recipe object to it. Lastly, we call Amplify API mutate and pass in the request. If the call is successful, we will update the local recipe as well. Let's restart the application and see how it works. Now the app is running, so let's try to update the image. In the details, click on the big image and select a new picture, and now image is locally updated. So let's try to send it to the cloud as well. Click on back, select yes. Now you can see that image is updated for Ramen. To see the update mechanism in action, let's run the application on a different phone. Let's sign into the application. As you can see, I'm logging in with my email address. Once I log in, you can see that pizza and the ramen has the same image. Let's do something for a change and update the image from here as well. I'm going to select a random image here. I will click back and say yes to this. You can see that after uploading, it automatically changed on both sides. Before we sign up, do not forget to update the names of local recipe repository and mock storage repository. In this video, you have learned about how you can create a GraphQL API, S3 bucket, how to do create, read, update and delete operation, query and observe data, upload and download files, and show information about the recipes. If you have any questions, do not hesitate to ask them in the comment section or on the social media. Thank you very much and have a nice day. In this video, you will learn about how we can set up and send push notifications. For running push notifications on iOS and Android, you will be expected to do a bit of setup. I will show you each step and how you can do it. If you're ready, let's get started. At the moment, if you click on the notifications bell here, you can see that it shows the pizza and ramen. These are local notifications and they do not show anything at all on the status bar here. But if you click on one of them, you can see that it takes us to the recipe details page. You can click on back here and click on back again. Let's create the actual functionality of. For that, open up your terminal again. For adding push notifications, write Amplify add notification. For Android, you will select FCM, Firebase Cloud Messaging. It will be the provider for push notifications for Android. For using cloud messaging, we need to create a pinpoint resource. You can name it as you want or use the default one. Also, they will ask you to allow unauthenticated users, so you can do configuration earlier on as well. So say yes to this. After everything is deployed, for getting the server key, open the Firebase console. Create a new project, give it a name. You can disable the analytics because we are not going to use it, and click on the create project. Once the project is ready, click on continue. Once you land to the page, click on the Android button here. Write the Android package. In case you don't know it, go to your build.gradle file and copy the value of application ID. Go back and paste it here. Even though this is optional, add the app name here as well. You also need to add debug signing certificate as well. For getting that, open up your terminal and run the command for listing the key store. Copy the SHA-1 fingerprint and register your app. Download the Google services.json file. Go back to your project, open the Android folder and the app folder. Copy your Google services.json file under the app folder. In your project, click on Next Now and be sure to add Google Services. For that, let's go back to our project again. Under the dependencies, you can see that we have the Google Services added here. Also for the build.gradle under the app, be sure to add the Google Services plugin. Go back to the browser and click on Next Now and return to the console. In the console, click on the gear button here and go to the project settings. Under the project settings, go to the cloud messaging. Under the cloud messaging API, click on the three-dot button here and click on Manage API in Google Cloud Console and enable this API. Once the API is enabled, go back to the Firebase console and refresh the page. You can see that now you have the server key and the sender ID. Copy the server key, go back to your terminal and paste the server key. Now the FCM channel has been successfully enabled and you can use notifications for Android. And now you did enough setup to use the notifications on the Android side. For seeing it in action, let's add the Flutter push notification library and send a test notification. Write Flutter pub add amplify push notifications pinpoint to add the library, and be sure that you run Flutter pub get to have the library in your project. Now go back to your IDE, open the configure amplify function in the main.dart file, and add the amplify push notifications plugin to the list. Normally, this should be enough to have the notifications running. However, Depending on your user's platform and operating system, it is likely that you will need to request their permission to display push notification. Find the handle permissions function under local notification repository and update it as follows. In this code, you will get the current permission status. If it's granted or denied, you don't have to do anything. When it is denied, if you want to do something about the denied status, you need to let the user know that they need to go to the settings and enable the notification permission manually. For the other statuses, you can just ask for permission. Now we should be ready for getting notifications for our Android device. So let's stop and restart the application again. Once you restart the application, a new dialog will welcome you. Click on Allow for this. Now that we allow, let's go to the pinpoint and send a test message. For that purpose, go to the Amazon pinpoint on the AWS console. Under the pinpoint, find your project and click on the test messaging. Select push notification, and under the destination, select the device token. For fetching a device token, go back to the project again. Fetching a device token is an operation that we are going to only do while sending test message. That is why, temporarily, we can call Amplify notifications push on token received function and print the token. Let's do a hot restart. And now you can see that we have the token. Copy that and remove this function. Next, go back to the console and paste the token here. Select the push notification service and create a message. You can select multiple actions and do even more customization. However, at this point, we don't need them. Let's bring back our device and send a message. Put the app to the background and send a message. You can see that we have received our first push notification. If you click on the notification, it will open the app. This shows we have configured the Android successfully. Now it is time to set up iOS. For iOS, you need a real device and an Apple developer account. So in this example, I would assume that you have both. First thing that you need to do is to create an app ID. Once you have an Apple developer account and a real device, sign into the Apple developer console. Click on the identifiers under certificates, IDs, and profile. Click on the add button here, click on continue, select app, and now we need to register the app ID. The app ID is crucial for creating certificates in the following steps. Add a description and the bundle ID. If you are curious about where your bundle ID is, open your project in Xcode, and under the bundle identifier, you will find the bundle ID. Now go back to the Apple console and paste it there. Under the capabilities, select the push notification, then click on continue. Check out the information and register. This app ID is used to identify your app in the Apple Developer Portal. Now it is time to create an Apple Push Notifications SSL certificate. This certificate is used to deliver push notifications to your app through APNs. You will create and download the certificate from your Apple Developer account. Then, you will install the certificate in Keychain Access and export it as a P12 file. Click on Recently Created App ID. Find push notifications and click on the configure button. Click on the production SSL certificate. For creating a new certificate, you need to create a CSR or certificate sign-in request. For that, first launch Keychain Access. Once you launch the Keychain Access, click on the toolbar, go to the certificate assistant, and click on the request a certificate from a certificate authority. Write the email address of your Apple Developer account, give a common name to your certificate information, leave the CA email address empty, choose Save to Disk, then click Continue, and save this to wherever you want. Once you create that, click on Choose File, and select the sign-in request. Afterwards, click on Continue, and choose Download to save the certificate to your computer. Once you download the certificate, double-click on that. It should open the Keychain Access, and if you do a research for your bundle ID, you will see the certificate. Right-click to the certificate. Before you export the Apple Push Services, be sure to select the My Certificate, and once you export it, select the P12 here. Name it as you like, and save it. You can add a password or leave it empty. It is up to you, but for the security reasons, always add a password. Next step is to register a test device. As mentioned earlier on, for tests and push notifications, you need a real device. You can see that the phone that I'm already going to be using is registered. However, I will take you through the process anyway. Click on the plus button here. Name the device, and you need to get a UDID. For getting the UDID, be sure to connect your iPhone with a USB port on your macOS device. Trust the device that you're connected to. Open the Finder app, and under Locations, select your device. Under the name of the device, you can see the UDID. If you see something else, click here, and you can see that you have the UDID information. And after you add that information, click on Continue, Review, and Register. And then you should be able to see the device here. Next step is to create an iOS distribution certificate. An iOS distribution certificate enables you to install your app on a test device and deliver push notifications to that device. In the Apple Developer Console, click on Certificate. Under All Types, select the Production. Click on the Add button, select iOS distribution for App Store and Ad-Hoc, click on Continue. Now we will upload the certificate sign-in request, meaning CSR. You can either create a new one for the new certificate, or you can use one that you have created earlier on. Using the same CSR for different certificates might cause security problems. So if you're testing, you can use the same CSR. However, for production, please use different ones. For that, go back to the keychain again, click on the keychain access on the toolbar, go to Certificate Assistant, and click on Request a certificate from a certificate authority. Fill in the user information, the common name, and select Save to Disk. Click on Continue. You can rename it to something unique. Select Save, go back to the console, choose that file, and click on Continue. Once you have it, click on Download. Once you download it, click on the certificate. It should open the keychain access and show you the certificate. Before we test push notifications, now we will create a provisioning profile. A provisioning profile allows your app to run on your test device. You create and download a provisioning profile from your Apple Developer account, then install it in Xcode. Go back to your certificates again, click on the profile. If you don't have any profile, click on Generate a Profile. Under the distribution, select Ad Hoc, click on Continue. Select the recipe application from the app ID, click on Continue. Select the newly created iOS distribution profile. Select your device, click on Continue, add a name to your provisioning profile, and click on Generate. Once you generate it, click on Download. After you download the provisioning profile, double-click on that. In response to double-click, the Xcode app will open up. This means all the necessary steps for testing out the push notifications has been added. For using push notifications on the iOS side, you need to go and open up your Xcode, go to the project, click on Runner here, and click on the target runner. Click on Capability here. Select the background mode, select the remote notifications and background fetch. Click on the capability again, select push notifications, and that should do it. But let's add the capability by using the terminal. To add the iOS push notification capability to our project, write Amplify add-on notification. You can see that we don't have the FCM anymore. Select the APN, meaning Apple push notification, select the certificate, drag and drop your P12 certificate, and click on Enter. If there is any password, write it down. If there isn't, click on Enter again. As you can see, the APN channel has been successfully enabled. So let's try to send a notification to the iOS as well. For that, go back to the project and get the device token like I have shown you before. Now that we have everything, let's rerun the application. As you can see, the app is asking you about the notification. Allow it. You can sign in with Google. After you sign in, now we are ready to send notification. Put the app to the background, get the ID, and open the pinpoint again. In the device tokens, add the new one, and select the APN, and send the message. You can see that we received a notification. If you click on that, the app will start. We have done enough setup to see the test messages. However, the test messages are not the best way to use the notifications, right? On a real life scenario, according to a certain behavior, you would like to send push notifications to the people. So you need a tool that you can use to automate this. Luckily, AWS has something called Lambda function. Maybe some of you heard about it, maybe some of you not. Lambda functions are cloud-powered dedicated functions that can be triggered with an event. In our case, we will listen to the database, and when there's a new recipe, we will send push notifications to the users. For add-in functions, open up your terminal and write Amplify add function. Once you run the command, select Lambda function, give it a unique name or select the default one, and select the runtime. Whatever language that you're comfortable with, you can select the runtime for that. In this example, I will select Node.js. Lambda functions gives you many templates. You can select one that you feel comfortable with. For our example, we will select the Lambda trigger, select the Amazon DynamoDB stream, and use the API category GraphQL that we have created earlier on. Select no to both advanced settings and editing. And now everything is ready locally. Let's check out how the project looks like. Under Amplify, Backend, Function, and the name of your function, you will find the Lambda function project. Our main focus will be on index.js. Update index.js like the following. Don't worry about the code part right now. You can find the link to the code in the video description. First, let's set the pinpoint client library. For that, go back to your terminal and go to the folder of index.js and write npm-i or install at AWS SDK client pinpoint. Once you add that, go back to your IDE. Let's quickly go through what we are doing. In this example, we will have an event every time when there is a change in the DynamoDB table. And for the records from the event, we will see the event name, and if it's insert, meaning that if we are creating something new, then we will send push notification. We get the title, description, and recipe ID. For sending a message to a group of people, we will use something called campaigns. Campaigns can define schedules, limitations, message configuration for each kind of message that you would like to send. After we create the campaign, we will send it with Pinpoint client. You might remember that Amazon Pinpoint was the service that we have used to send push notifications. By using its client, we will send down push notifications programmatically. For creating a client, you need to define the region in the project that you created, and you need to have the Pinpoint client installed. You need to have proper permissions to create campaign and send down messages. For adding permissions in AWS world, you need to create policies. These policies will allow you to do some operation. For creating policies, go to your AWS console. In AWS console, find IAM. Go to your user that you've used to create this project. Click on the user and you can see that we have policy name. In the end, we will create this policy, which is called pinpoint specific for notification. You can name it anything that you want as well because this is a custom one. But if I open this up, you can see that I have permissions for creating campaigns, getting campaigns, and sending messages. Let's see how you can create. First, click on add permissions and click on create inline policy. You can specify a service. Let's search for pinpoint. Select the pinpoint here. You can either select everything, which we don't want to do, but what we want to get is get campaigns, create campaign, and send messages. It will ask you to add an ARN, which is Amazon resource. Select any in this account and any in this account as well. Click on next. You can name the policy and click on the create policy. After you click on it, you can see that you have another one here. Once you open up your policy, you can see that we have the create campaign, get campaigns, and send message. You can use this one as well. Also, you can get the resource and combine everything like we have here. You can find the link to this policy as well in case you want to use what I have. Just be sure that you have the correct ARN. So for being sure, you can copy this one, paste it here. After you create it for this user, go back to your ID. In your ID, go to the custom policies like JSON and copy and paste the policy that you created earlier on. After updating the policy, go back to index.js. You can see that we are missing two IDs. One is the app ID, the other one is the segment ID. For this purpose, open up your AWS console again. In the console, go to the Amazon pinpoint. Once you open up your pinpoint, find your project and get the ID. Go back to the code and paste it as the app ID. Go back to the console and click on the project. We need to create segment. For creating that, click on the segments, click on the create segment button. We will call this one recipe listener segment. We will include all the audience. So far the registered people are 2 endpoints. So we will have the 2 endpoints and click on the create segment. Select I understand, copy your segment ID and go back to your code and paste it here in the segment ID section. Thanks to the segments, you are able to identify your audience. And thanks to the campaigns, you can create campaigns. You can create targeted actions towards them. Now, let's push the Lambda function to the cloud. For this purpose, go back to your terminal and run Amplify push. After the deployment is successful, let's see the Lambda function in action. After the deployment, now we have 2 versions of the app running, iOS and Android. What we are going to do is to put the Android app in the background and create a new recipe from the iOS. We selected a cake and click on the check mark. You can see that now we received a new recipe notification, and it also gives us the name of the cake as well. If I click on that, you can see that the app is open and we have the cake. However, we don't have the cake in the notification. Let's add the logic to add that as well. There are many ways that you can actually save the notification, but each require you to interact with the push notification. For that purpose, we need to talk about something. There are many cases where it's helpful to interact with push notifications, but it all depends on your application state. What do we mean by this? When the app is in the foreground, like you have seen here, the app is running, it is active and visible. In this case, you will not see a push notification badge from the top. If you swipe the app to the up, now the app is in the background state. It is still running, but it's not currently active and visible. In our case, we are in the home screen. Lastly, the terminated state. If you go to the app switcher and move the application up, your app is no longer running even in the background. The user can initiate this by swiping your app away. To be able to save this information, we need to have our local database ready. You can also create another Lambda function to save it to the cloud, but we are not going to do this now. In our case, when we receive the push notification on the foreground, or when it is open, we will save the push notification information to our local database. For that purpose, go to your local notification repository and find listen notification. Update the function like the following. First change that we are going to do in the listen notifications function is add the ability to list foreground notification. For that, you will write amplify notifications push on notification received in the foreground. That will return a stream and you can listen. Once you listen to that, you can see 2 things. First thing is we have a title and a body for the notification. And the second thing is we have a JSON body, which is containing recipe ID, recipe title, and description. In the handling part, we get the pinpoint body, which is the JSON body, to have the title, ID, and description for the recipe. And we get the title and the body that we have defined before directly from the notification object. If you run the application now and add a new item, you can see that the item is added and the notification has a new green dot. If I click on that, you can see that it shows new recipe, check out CBAT. If I click on that, it will take me to the created object. If I go back again, you can see that I have the item. Another way to handle the push notification is to check when a notification is open. For that purpose, you will write amplify notifications push on notification open. This will return a stream and you can listen to it and act on it. The rest of the implementation will be the same. So let's put the app to the background and create a new push object again. You can see that we have a new notification. Let's click on that one. Once the item is opened, you can see that we have the new notification sign. If I click on that, you can see that I have the item. If I click, it will show me the new recipe. Now you learned about how you can add authentication, GraphQL API, file storage, and push notifications by using AWS Amplify with Flutter. If you take a look at the app now, you can see that you can favorite some items, you can scroll through them, go and see the favorited item, pick out your profile, search for an item, go to details of it, favorite it, go back, and you can see that all of the pages are reactive. Lastly, you can go and click on logout to leave the user. Thank you very much for being part of this video series. If you have any questions, do not hesitate to ask them in the comment section or with the social media link. Have a great day.